Fourth grade lesson 12.5 is line plots. They're also called dot plots too as you go in the upper grades, but same idea. Let's get started. Our essential question is, how can you make and interpret line plots with fractional data? The data shows the lengths of the buttons in Jen's collection over here. For an art project, she wants to know how many buttons are longer than 1/4 or 1/4 inch. You can use a line plot to solve the problem. A line plot is a graph that shows the frequency or how often the data goes along the number line. So here's the length of buttons in Jen's collection in inches. There's a 1/4 inch, a 3/4 inch, a 1/4 inch again, a 4/4 inch. Remember, the same number numerator with denominator. That means a 1 full inch, 1/4 inch, and 4/4 inch. Let's make a line plot to show the data. You would order the data from least to greatest length and complete the tally on the table. So we have the 1/4 is the smallest, then when we look through there, 3/4 is the next amount, and then 4/4 is the biggest amount. So let's go ahead and go through this. We have a 1/4, there's one of them. Oops, let's do it better color, 1. This is the tallies. 3/4, there's 1. 1/4 again, so that's another one, another tally mark. 4/4 or 1 whole, there's a tally mark for that. 1/4 again, so there's another tally mark. And then 4/4, okay, right there, 1 whole. So now we'll label the fraction lengths on the number line below from the least value to the greatest value. So we have 0 and 1 whole. I'm going to extend this out. So this is 1/4, 2/4, 3/4, and 4/4, 1 whole. I just extended that out only because I think they wanted me to put 1/4 here, but I really wanted to see 0 on the line because I'm still trying to train your brains to recognize that these fractions fall between 0 and 1. They're in-betweener numbers. I'm going to clean this up a little bit. Okay, there we go. There's my number line, 0 and 1, and in the in-betweeners, 1/4, 2/4, 3/4, and then of course you know that 4/4 is 1 whole. So now we will just go ahead and put plots on each of the ones to replace the tallies. So for 1/4, we have 1, 2, 3 plots that we're going to do. So we'll say 1, 2, 3. For 3/4, we have 1. And for 4/4 or 1 whole, we have 2. I guess those colors aren't the best choice of colors, are they? Okay, we'll go black there. How many buttons are larger than 1/4 inch? Well, these 3 are 1/4 inch, so how many are larger than just these 3 over here? So the line plot is that we have a line and then we kind of plot out which numbers we've got here, and we can see them stack up above each other, and it makes them organized in a way that's easier to count. How many buttons are in her collection? Well, there's 1, 2, 3, 4, 5, 6 in her collection. And what is the difference in length between the longest button and the shortest button? When we're looking for difference, what calculation are we doing? Yes, we're subtracting. And we have a 4/4 is the largest. We'll take the 4/4, the largest one, and subtract from it the smallest button in her collection, which is 1/4. And that gives us the difference between them. 4 minus 1 is 3/4 is the difference. Example 2. Some of the students in Miss Lee's class walk to school. The data shows the distances these students walk. What distance do most students walk? Here's the data. They walk in miles, 1/2 a mile, some of them 1/4 of a mile, some of them 3/4 of a mile. We're going to make a line plot to show the data. In step 1, they want us to order the data from least, smallest, to greatest, largest distance, and complete the tally table. Okay, well, I have 1/2 a mile. Not sure if that's going to be a smallest or largest. I'm just going to put it in the middle so I can manipulate either way. That's a 1/2 already. 1/4. Okay, remembering what we know about these fractions, if you're only getting one piece and this person has to share one piece out of that pizza with 4 people, and this person has to gets one piece but only has to share with 2 people, this guy's getting a bigger piece because split 4 ways, that's a smaller piece, so 1/4 is smaller than 1/2. You could have also said Well, I know that 1/2, the equivalent fraction for 1/2 with a 4 denominator is 2/4. 2 is half of 4, and 2 is bigger than 1. You could have done it that way, and that'll help you with this next one, 3/4. If the equivalent of 1/2 is 2/4, then 3/4 is larger than that. Any other fraction measurements? Nope, those are all the same. Okay, there we are from least to greatest. So we have 1/4, 1/2, and since those other ones have a 4 denominator, we can write the equivalent of half with a 4 denominator, 2/4, and 3/4. Now let's tally up how many of each of those that we have. We have 1/2 and 1/2, so I'm going to put 2 tally marks on 1/2. Then we have 1/4. I'll put 1 tally mark on 1/4. Then 3/4, I'll put a tally mark there. 1/4, I'll put a tally mark there. And then 1/2 and 1/2, 2 tally marks for that. Here's the frequency for how often each of those turned up. We're going to go ahead and put an X above the number line for each data point, and write a title for it. So this is miles walked, And you know I like to have the 0 and the 1 on my number line so that I'm training your brains to recognize that these fractions fall in between. So let me just fix up my number line real quick. All right, there's my number line all fixed up. I extended this out to put the 0 here, this out to put the 1 there. We have 1/4, and then the next segment is 2/4, also known as 1/2. The next segment is 3/4, and the next segment is 4/4, also known as 1/2. Now let's go ahead and put the X's above these for its frequency. So we had 1/4 show up twice. Then we have 1/2, also known as 2/4, show up 4 times. Oops. 1, 2, 3, 4. And then we had 3/4 show up once. So most student walks how much? Well, we can see now, both here and here, most of the students walk 1/2 a mile. How many more students walk half a mile than 1/4 of a mile? Where there are 4 people who walk half of a mile, and there are 2 people who walk 1/4 of a mile. So how many more? Anytime we're faced with how many more, we're going to do a subtraction. So there are 2 more people who go half a mile than there are that go 1/4 of a mile. What is the difference between the longest distance and the shortest distance that the student walks? The longest distance is 3/4 of a mile. And the difference between them, by now you know the difference between is subtract. Between that and the smallest distance is 1/4 of a mile. My denominators are the same, so it's no problem to go ahead with my subtraction. 3 minus 1 is 2. So the difference between them is 2/4, also known as 1/2. What if a new student joins Ms. Lee's class who walks 3/4 of a mile to school? How would the line plot change? All right, well, let's add that on there. 3/4 of a mile. There's that new person. And the line plot we just add an X over 3/4. I guess that's how I would describe the change. Okay, let's do the share and show, and then I think you're probably ready to tackle this on your own. It's just pieces of information you already know. You're recognizing the fractions pretty easily now. We're just getting them in order and marking their frequency. A food critic collected data on the lengths of time customers waited for their food. Order the data from least to greatest time. Make a tally table and a line plot to show the data. Okay, I'm going to go least to greatest, start by looking at this. 1/2, I'll put in the middle. 1/4, right? If we're sharing with 4 people, our pieces are going to be smaller than if we only have to share with 2 people, so that's smaller. 3/4, this is 2/4 equivalent, right? So 3/4 is more than that. And 1/4, we have that. 1/4, we have that. 1/2, we have that. 1/2, also known as 4/4, right? We can put 4/4 or just 1 whole. We know that's the biggest of them all. 4/4 is all of it. Okay, these are our numbers, so we're going to put the time in hours that people waited for their food. Some customers had to wait a long time. 1/4. 1/2 is the next biggest. 3/4 is the next biggest of an hour. And then 1 full hour they waited for their food. Oh my gosh, that's a long time. Let's tally these up now on how frequent these happened. 1/2 hour goes here as a tally. Then 1/4 has one. 3/4 gets one. 1/4 and 1/4 again. 1/4 and 1/4 again. 1/2 and then 1. 1/2 and then 1. There is our frequency table. Let's go ahead and lay these out on the number line with our dot plots or our line plot things, our X's up here. I'm going to extend this number line again just to cover all of the between 0 and 1. Okay, so I extended this so that I could put 0 there between 0 and 1 whole, also known as 4/4. I have 1 segment, 1/4, 2/4, 3/4, 4/4. There we are. Now let's put our X's up here for the frequency. 1/4 has 3 X's. 1/2, also known as 2/4, has 2 X's. 3/4 has 1 X. And 1 whole, also known as 4/4, has 1 X. Oh, and we need to label it. This is a time waited. Time they waited for their food. Poor guy over here waited forever. He was probably starving. All right, there is our line plot completed. Now that these are all completed, we can easily answer the questions on how many customers did the food critic collect data. 1, 2, 3, 4, 5, 6, 7 people. That's a 7. And what is the difference between the longest time and the shortest time that a customer waited? Difference is your key word. Bing, bing, bing. Difference means subtract. So let's take the longest time they waited. It's 1, but we know we're subtracting, so let's make that 4/4. And the shortest time that customer waited was 1/4 of an hour. The difference between them is 3/4. 4 minus 1 is 3, and there you go. That's all this is organizing the data, practice of ordering those fractions again because we don't want to forget that, recognizing getting the extra time on those practice in, and then being able to use the organization of the data in order to answer questions. I think you're going to be fine on this. Good luck. Let me know if you need extra help.